Good morning, students. So dear students, today we are going to start an amazing chapter, a chapter of great importance in physics, that is motion. The terms and parameters used in this chapter are very much related to our day-to-day lives. So let's start this chapter. So before starting this chapter, we need to know certain things which we already use in our day-to-day lives, like an object is in motion or any object is in rest. So when we are talking about any object is in rest, we mean that the initial position, which is the starting position, and the final position, which is the ending position. So the starting and ending position are same. So in that case, we can say that the object has not undergone any change in position with respect to time. So such type of object is said to be at rest. On the other hand, when we talk about any object is in motion, that means the initial position and the final position of the object are different from each other, which means that the object has undergone change in position with respect to time. Then that type of object is said to be in motion. Now, when we talk about motion, there are various types of motion. For example, rectilinear motion, curvilinear motion, oscillatory motion, rotatory motion, vibratory motion, multiple motions. Okay. Next thing that we need to know in this chapter is all about, that means all physical quantities can be classified into two groups. The first group is with respect to scalar quantity, and on the other hand we are having vector quantity. When we are talking about scalar quantity, it is such a quantity in which only magnitude is measured. But on the other hand, when we are talking about vector quantity, that means it is a quantity in which magnitude is measured along with the direction. Just see the difference between them. In scalar quantity, we are having only magnitude, and in vector quantity, we are having magnitude along with direction. Okay. Now, let's move on to the examples of scalar and vector quantity. When we talk about examples of scalar quantity, we are basically meaning that only magnitude will be there. So, the examples can be length, it can be area, it can be distance, etc. On the other hand, since vector quantity is having both magnitude and direction, so such examples can be displacement, acceleration, torque, etc. Now, when we know the difference between scalar and vector quantity, now we can easily define the differentiate the two parameters, that is distance and displacement. When we are talking about distance, distance is basically the actual length between the initial and the final position. Then we say it to be as distance. But on the other hand, when we are talking about displacement, displacement is the shortest length between the distance, between the initial position and the final position. Just try to understand the concept. Main concept is all about distance means it is the distance between the initial and the final position. Okay. And when we are talking about displacement, displacement is the shortest length in between the initial and final position. In case of a straight line, when we are talking about a straight line, if a body is starting from point A and undergoing a straight path to point B, then distance and displacement will be same in that case, because the shortest length and the actual length in a straight path is going to be the same. But in case of a circular path, let us consider a circular path where the initial position of that path is A and the final position, let us consider it to be as B. In such a case, when initial position and final position are coinciding with each other, in that case distance and displacement are going to be different. Let us see what it will be. So in case of distance, distance means it is the actual length of that circular path. So what is the circumference of the circle? Because the distance is going to be equal to the circumference of the circle, which is going to be 2 pi r if we consider the radius of that circular path as r. On the other hand, when we are talking about displacement, displacement in that case, since the shortest length in between the distance, in between the initial and final position is same, so the displacement in the circular path is always going to be 0. Okay. Why it is 0? Because the initial and final position in case of a circular path is same, so there is no shortest length due to which the displacement is going to be 0. Okay. So this is very important thing that you need to know while doing certain numericals. Now the next difference that lies here in case of distance and displacement is Distance is a scalar quantity, that means it is having only magnitude with no direction. And when we talk about displacement, displacement is a vector quantity, that means it is having magnitude along with direction. Third point, that is the third difference in between distance and displacement, is then distance is always positive. We always get a positive number since it is magnitude, so we always get a positive number. When we talk about displacement, right now whatever example I have given you with respect to a circular path, that in that case the displacement has become 0. So displacement can either be 0, it can be positive, it can be negative even. Okay, so these are the differences in between distance and displacement. Now when we know the difference between displacement and distance, now we can relate the difference between speed and velocity. When we are talking about the main difference between speed and velocity is then, speed is the distance traveled per unit time. Okay, what is speed? Speed is the distance traveled per unit time, which means that speed is something related to distance. On the other hand, when we talk about velocity, velocity is somewhat related to displacement. That means we are going to consider the direction in case of velocity, magnitude along with direction in case of velocity, and in case of speed we are only going to measure the magnitude irrespective of its direction. That is why we can define speed as it is the distance traveled per unit time. And when we are talking about velocity, velocity is the distance traveled per unit time in a definite direction. We are considering this as definite direction. Okay, so the second point or the second difference in between the speed and velocity is that speed is a scalar quantity since it is having only the magnitude, and velocity is a vector quantity since it is having magnitude along with direction. So again, the third point comes from the distance, like the difference of distance and displacement we have already done. So speed is always positive since distance was always positive, and velocity, it can be positive, negative or 0 as in case of a displacement. Now speed formula becomes distance traveled per unit time, and velocity's formula becomes displacement per unit time. Okay, so these are the two formulas which we are going to use in our numericals. So let's recall what we have learned today. We have learned about object is in rest, object is in motion. We have also discussed about the difference between the two quantities, that is scalar quantity and vector quantity. We have discussed about the difference in between distance and displacement, and in relation to distance and displacement we have also discussed about the difference between speed and velocity. Now let's move on to the next part, that is average velocity. When we are talking about average velocity, before knowing what is average velocity, we need to know two terms. One is initial velocity and the other one is final velocity. When we are talking about initial velocity, it is denoted by small letter u, and this is the starting velocity with which any object starts. Now when we are talking about final velocity, it is denoted by small letter v, and which means the end velocity. Okay, now average velocity means it is the sum up of both the velocities. That means if numerically, if I want to tell you what it is all about, average velocity will be equals to u plus v by 2. U is the initial velocity, which is the starting velocity. V is the final velocity, which is the ending velocity. And when we sum up both of them and just divide it with 2, we get the average velocity. So hope you all have understood all the things being explained to you. In our next class, we will discuss the rest of the things.